All right. So today we're going to talk about front-end testing. And for part one of this lecture, we're going to talk about why testing matters, different kinds of tests, and what should I write tests for. We will review test-driven development a little bit, and we'll talk about the tools that are used for testing to get familiar with, particularly on the front end, Puppeteer and Cypress. In part two of the lecture, we will actually start writing some Cypress tests. So let's go ahead here and dive on in. So we've talked a bit about testing in the past, but just to kind of reiterate here, why is testing important? As software engineers, our job is to um, deliver reliability, right? And consistency. If we're working at Amazon, which I just love to use as an example because their website, you know, probably makes millions of dollars a minute, and I'm pushing a change to that site. How can I guarantee my change will work and not break things? Well, I can manually test it. I can manually review the code. I can write my code in such a way that it's harder to make errors, right? So best practices and good design. And then I can write other code to test my code. And this is testing. And so all of these matter in terms of software quality. You can't really replace one with any other. So testing is really important, but by itself, not enough to deliver software quality, right? I need to be following some best practices for writing code, by using Bootstrap and Bootstrap's layout tool. Instead of building a layout tool from scratch, I'm using a library that's been used by tens of thousands of people that's had all the bugs ironed out. By having not just me, but other people review my code, I'm anticipating that human error is a normal part of programming. And rather than trying to be a perfect automaton, we're going to build review into our process. And I'm going to manually test my code, but the QA team is going to also do it as well, right? And when you put all these processes together, then you get reliability consistently. And you can do it in a way that's efficient and cost effective. So testing is important because it's automated, right? Unlike these other processes that are manual, like testing, once I have it written, then I can run the tests and it should be able to tell me 100% of the time if it's right or not. Now, in practice, tests are easy to break when code changes. Tests can take a lot of work to write. Tests can't find errors that we don't test for, right? Who tests the tests, so to speak. So testing is really valuable, but it has limits. And to address this, there's different kinds of testing. There's what's called end-to-end tests and integration tests and unit tests. And I know we've talked about this a little bit before, but I think it bears repeating. A unit test focuses on one specific unit or part of my code in isolation to make sure that it behaves correctly. For example, testing a single React component or testing a single JavaScript function. Excuse me. Integration tests combine several different units together. And in Python, by the way, another example of a unit test would be testing a single Python class, its methods, and so on. Integration tests are all about testing how different units of code interact, right? So testing how maybe like multiple React components or JavaScript functions interact. Right? I want to make sure that my data is getting passed around correctly. A lot of the times, integration tests are often about checking data is passed correctly through my program. As you can see here, each kind of testing has strengths and weaknesses. Unit tests are fast. They can pinpoint individual issues. They can give us a nice safety net or test harness. They can miss bigger picture integration issues. My class or my React component might work fine on its own, but if some other part of my program is passing in bad data as a prop, then my unit test won't catch that. Integration tests can catch that, but they start to be slower, right? So kind of there's a theme here, and the end of this theme is what's called an end-to-end test, which tests my application by simulating exactly what a user would do. Right? So this tests my code by simulating like real user input, testing the code end to end from user input all the way to output to the user. So for example, this might be testing when I click a button in React to fetch a Pokemon that we see the desired Pokemon rendered on the screen, right? So when I'm writing an end-to-end test, I want to test my whole program from end to end. Or for example, testing for a REST API, when I hit an endpoint, I get the correct data in my response. So end-to-end tests are kind of the most powerful because we're really simulating full on our application running, but they take more work to set up. And especially for code running in a browser, it's even trickier. And there's a great term called the testing pyramid. And as you can see, unit tests are at the base of the pyramid. And for service tests, this is just another term for integration tests. And for UI tests, this is another term for end-to-end tests. And basically, unit tests, they're more isolated, right? But end-to-end tests are more integrated. But what also needs to be on here is time and effort. Right? And one of the nice things about unit tests is they're lower cost in terms of time and money, writing the test, maintaining the test, and end-to-end tests are definitely higher cost. I grabbed this diagram from a great article by this guy, Martin Fowler, who's pretty known in the software engineering community. And I will share this link with everyone. And I do recommend giving this article a read as it goes pretty in depth into testing. And this is from his blog, but he's written a couple books, one on refactoring, which involves writing a lot of tests that have sort of become like standard things to read in the world of software engineering. Um, there's a lot of great diagrams for the testing pyramid, by the way. If you just sort of Google for it, we can see there's a couple, all sorts of different diagrams, all kind of talking about the same thing. But at the end of the day, I think there's a pretty like intuitive balance between sort of like complexity and effort. And I just want to pause here and see if folks have questions or stuff that we're curious about with this sort of bigger picture stuff. Okay, cool. Now, I know some of this might be a little abstract. This is actually really important. Like everywhere I've worked as a software engineer, all my code that I wrote, I needed to write tests for. And when you all join a software engineering team, it'll be the same. And in fact, as your portfolio projects get more complex, writing tests for them is one of the best ways to signal to anyone reviewing your code that you kind of like understand the role of a professional software engineer, right? Because tests are not necessarily fun, but again, going back to this point of like, as software engineers, our job is to deliver reliability and consistency. Like, so I'm not just saying, trust me, it works. I'm saying I can guarantee that it works because we're using all of these processes, then testing is essential. Also, as my program gets bigger, when I want to change code or modify it, having tests to tell me if when I'm refactoring or modifying code, if I've introduced a new bug is really valuable. And in fact, that guy, Martin Fowler, came up with this term called a test harness. And let's see here. None of these examples are really giving me the description that I want, but I think the analogy is that if I have a program and I want to change it, but I want to make sure I don't introduce bugs, if I have a bunch of tests, it's like a harness or a safety net that catches me. And so as my code gets bigger, the tests actually can become my friend and help me write code faster and change stuff. There's also something called a regression test. Basically, if we find a bug in our code, once I fix the bug, I'm going to write a test for it. And that test is called a regression test because first, I want to verify that the bug was fixed. But second, if the bug made it through the manual QA and it made it through code review and it made it through our other tests into a live site, then by definition, it's a tricky bug because we missed it with all this stuff. And you all would be surprised how often a bug gets fixed and then reintroduced later. And so a regression test makes sure that when we fix a bug, we don't regress or go backwards and accidentally introduce the bug again. Right. And so this is stuff that right now is not as applicable, right? We're still building smaller programs, but to use the analogy of sort of learning the tools to build a skyscraper, right? To go from like a doghouse to a gazebo to a house to an office to like maybe a small office building to a skyscraper, then the bigger our programs get, the more important these things start to become. And if you think about a massive program with dozens of engineers working on it and tens of thousands of lines of code, then you absolutely, if you think about Netflix, then you absolutely need tests. So, as mentioned, testing has trade-offs, right? And that's really what software engineering is all about, is being able to talk about trade-offs, right? So the benefits are all of these things, bug detection, quality assurance, maintainability, and even collaboration. Tests work really well as sort of living documentation. However, tests are time consuming. This is sort of notorious if you talk to any software engineers in the industry. Setting up the code to run tests takes a lot of effort. And then there's what's called test coverage. How much of my code does the tests cover? is if I run all my tests, does that execute every single line of code? Or is there code that is maybe a method or a function that isn't being covered by the tests? Test-driven development, I believe we've talked about a bit in the past, but so I'm not going to dive into it too much now. But in essence, the idea is you actually use testing as part of your process of writing code. And the way that I do this in practice is I might not full on write tests first, but I will try to write some skeleton code and some pseudocode and use print statements and run my code like every 5 minutes. So I can use my print statements to sort of manually test as I go. And then I do follow this workflow of I write the code and it's failing, and I keep writing code until I get a little bit passing, and then I refactor as I need to clean it up. And if you think about trying to run your code like after every couple lines that you write, and you think about, all right, I've written 5 lines of code, how can I add a print statement to test that the code is doing what I want and run it? Then that's the mindset that'll kind of take you on the right path. So I'll come back to React in just a moment because it's opening a bit of a deeper well. I do want to give a bit of a preview of some testing frameworks that we're going to see later in the course when we look at Django. Um, there's one called Django Test Case, and then a framework that we'll use called Django REST Framework has a class called API Test Case. And in fact, if we take a look at these just very quickly, just to kind of start to see what this looks like. We see some Python code that we know and love. We see something about models, about representing our objects in a database. And we see that we have to run some setup code to create fake data for the tests. And then we have tests to actually run the code and make sure that our code works. And we'll learn more about this later. But let's talk a bit more now about libraries and testing for React. And the challenge with React, and up here I have the Vite project that we know and love running. And we have some source code, and it's right now just the simple hello Vite, where I click on this button, and it might be nice to be able to write a test to make sure that this is working. Well, if I want to write an end-to-end test to do this, my challenge is this code is running in the browser, and I really need to simulate the browser. So for front-end end-to-end tests, to do any sort of end-to-end testing in the front end, we need to be able to simulate the browser. And then we need to be able to click on buttons, etc., and do all the things a user would actually do in the browser. And there are a couple tools out there to accomplish this. The sort of fundamental tool is called Puppeteer. So Puppeteer, it's a JavaScript library, but it actually lets us control a browser. It actually lets us run Chrome or Firefox, and I can actually run the browser without a UI. And so if I'm to hop over here to TLDraw, over here on my command line, right, or really my shell in my computer, I might be running Puppeteer. And Puppeteer is actually then going to run inside of it. It's going to run a browser, say Chrome, but it's going to run it what's called headless, which means no UI. So I'm not going to actually see a browser. And then inside there, I can actually run my JavaScript code. So I can actually run my JS code, which is going to be my React app. So we actually have a lot of different layers here, right? I have Puppeteer running a browser inside my computer. And so this is sort of the scenario for front end to end testing. And it's pretty similar to like how we would actually use an app in the real world. Right? Except in the real world, I'm not running a browser from the command line. It's just running, on my desktop and on my computer. And in fact, then there is no Puppeteer. And in fact, I have my browser, Chrome, running like normal. And then my JavaScript code is running inside there. Right. And so the key differences here is Puppeteer is, as the name implies, sort of like pulling the marionette strings of the browser. And we're running a special version of a browser that doesn't have a UI, so I can run it from the command line. Now we're going to see we can actually have a browser UI, but this is sort of the core concept. And like we can actually run a little bit of Puppeteer just to see it. We're not going to actually use it. We're going to be using something else called Cypress, but just to kind of demonstrate this, I think it is good to see. So let me go ahead and move into my project directory. And this isn't code that you all will have to run. This is more, I just want to run this sort of for example purposes. Just so we can kind of see what we're talking about when we're talking about a headless browser. And we'll sort of give this a minute to install. And while it's doing that, we can kind of look around their docs a bit. Oh, there we go. Perfect. It's installed. It has a lot of different methods to run, a lot of different functionalities in the browser. Again, in just a minute, we're actually going to see this other tool, Cypress, that makes this process a lot easier. But I just kind of want to demonstrate the basic sort of example here so we can see it in action. So in fact, I'm just going to make a file and we'll just name it Puppeteer example.js. And again, this isn't anything we'll have to run or do, but I just want to sort of like show some examples. And I'm just going to copy and paste this code in. And if we kind of look through this code a bit before we run it, we'll see some things we're familiar with and some things that are new. We'll see we import the Puppeteer library. We see await. So this is telling us that Puppeteer is going to kind of run all of this within an async function for us. I may actually have to modify this code a bit to get it to run. But we see we're launching the headless browser. We're creating a page. We're navigating to a real URL. Right? If I put that in my browser, we actually see indeed we're going to the Chrome Developer Tools page. We see we're setting the size of our browser. Even though we're not going to see the UI, there's still a viewport, and for rendering stuff, it all needs to be there. We see we can use Puppeteer to press a button on a keyboard. we see we can use sort of query selectors to grab a search box, right? So Puppeteer is simulating if I'm here on Chrome Developer Tools and I just hit that slash button to open up that search bar. And in fact, if we use the Elements tab to inspect the search bar, if I can get it open and we can look at it at the same time. Yeah, and it's a little annoying because it when I click away, it doesn't seem to want to do it, but here we go. We can kind of see what's going on. And so when you're writing these front-end tests, you do have to know how the HTML is organized in terms of both HTML and CSS so that we can grab elements. And we're typing into this search bar something. Automate beyond recorder. And then I'm hitting enter, or I'm clicking on the search button. And then we see search results. We see here that the code is waiting for that page, and then we're trying to grab text content and we're trying to print it out. So now that I've kind of manually walked through what Puppeteer is doing here, let's go ahead and let's run this code and see what I need to modify, if anything, to get it to work. I suspect the main thing may be all of this may need to be wrapped in on a wait. As you all are probably learning, sometimes like code in documentation, they kind of make some assumptions about stuff. And let me go ahead and save this file and let's run it and see if it works. And actually, it does appear to be running. And it looked like it ran just fine. I think maybe Puppeteer handled the async await for us. And then we see printed out here, the title of this blog post is, and then we see stay organized with collections, save and categorize content based on your preferences. Let's see if indeed, interesting. It doesn't look like that's exactly what we got. So I have automate beyond recorder. So I wonder what the difference here is. And this is where like using these tests can get a little tricky. But just to give an example of this, like if we go back to the Chrome Developer Tools page, and we kind of get back to the home page for it. If we look at this message here, which is probably an H1, and we see it's actually an H2. And let's try and maybe grab that H2 before we do all this stuff. And I may, I apologize. I'm actually less familiar with Puppeteer, and I think I might get a little lost in the sauce trying to write this code out to get it to run with locator and wait handle. So I think we'll give this a quick shot, and then if it doesn't work, we'll pause. So we just want to print page title. And I want my locator to be just a plain old H2, I think. And we'll just call this H2 selector. And we'll call this H2 title. And let's see if we can print it out. So in fact, that did work, which is great. I see here a powerful web made easier, which is indeed the title here in the H2. So there are a couple hoops we had to jump through with Puppeteer, but I was actually able to grab this. So why does this matter? Why am I talking about headless browsers and Puppeteer and something that we might not even use? In fact, that we're not going to directly use? Well, Puppeteer is great, but as you can see, there's a lot of manual steps. And if I want to write end-to-end React tests, it might be a bit of a pain. And that's where Cypress comes in. So under the hood, Cypress is a library that actually does use Puppeteer because it needs something to run the browser, headless or otherwise. And in fact, it gives us a much nicer user interface for doing all of these things. So we're going to be able to actually run our React app in the browser. It will actually, if we want, record videos of the test clicking through things. And it can actually take screenshots and we can actually do some debugging in the browser. And if we take just a quick look at the docs, and we'll take a break before we dive on in. But if we look at end-to-end testing and we look at the code here, we'll break down what this means, but we see that there's a lot less steps involved in going to a website. Right here, we're going to the Cypress IO page. Here, we're using a query selector to grab a bit of the page based on what HTML element it is. And we're writing something in there. And we're even able to look at the search results and see that it should only have one thing inside of it. Right. And what this test is simulating is going to the Cypress homepage, cypress.io. And then I believe entering in the search bar here and entering in write tests, and we're grabbing that first search result. So Cypress is going to make a lot of these things easier. There are several concepts that got introduced here. The biggest of which is this idea of a headless browser or a browser sort of being controlled by a program. Because what we will end up doing is instead of Puppeteer, we will use Cypress, which then is using Puppeteer under the hood, but we don't have to worry about that. And then we can write tests that will actually run Chrome and actually run a React app in it, which will give us a really good simulation of what happens in the real world when a user is clicking on our app. So this is a good pause point because after this, we'll take a break and then we'll actually start writing some Cypress code. I do want to see what questions folks have or what people are curious about with the things that we've been going over, whether it's about sort of the big picture of testing, right, and the different kinds of testing or the test pyramid, or anything kind of related to this idea of a headless browser or using JavaScript code to like drive and control the browser like with Puppeteer and Cypress. Tom, yes, sir.
So with the Puppeteer, did we not need to write an async function because it was headless? And we didn't necessarily have to wait for everything. We could just keep on barreling forward if it was encoded in the HTML.
It's a good question. I'm honestly not quite sure. Um, I suspect that when we use the Puppeteer library, it might be wrapping stuff in another async function that's doing the sort of async stuff that we're used to. But that I'm actually not sure. Yeah, that's a good question. My money for what it's worth is on something happening with this Puppeteer launcher, this import statement, but I'll try to check and follow up because I was a bit surprised by that as well. All right, why don't we take 10 folks, and then when we come back, we will start writing some Cypress tests. And I think you all will be pleasantly surprised to see how straightforward it actually is and how powerful it is. So thank you guys, and I'll see you all in 10 minutes.